thing we're dividing by cannot be 0. So Friday what we talked about was the domains of these things. And that was what made the bottom 0. In the last couple examples, we compared the domain to the graph, and we found out that where you had your domain issue was where we had a vertical asymptote on the graph. And we said there are 3 different types of asymptotes: horizontal, vertical, and oblique. So today we're going to focus on how to identify those from the equations. So you have a rational function. First thing, vertical asymptotes are x equals a number that is a 0 of the denominator. So any number that makes the denominator 0 is a vertical asymptote. Asymptotes are lines. So when I ask you for the asymptote, you can't just say 3. You have to give me the equation of that line. So you have to say x equals 3. So it's kind of the opposite. The domain, you're telling me x cannot be 3. The asymptote is x equals 3 because it's that equation. Horizontal and oblique. The rules are a little bit different. Horizontal lines are y equals a number. And they're found by dividing all the terms of the greatest degree. Okay, and I'm going to talk about this a lot today, but we divide the terms of greatest degree. When we have oblique, this happens when the degree on the top is 1 more than the bottom. And to find it, we have to do long division. Horizontal and oblique all really come down to dividing the polynomial. So what I'm going to do when we work through the first few, I'm going to treat them all as a division problem, and then we'll talk about what the pattern is from there. So if you remember the pattern, you wouldn't have to divide every time, but if you don't, that same strategy would give us all of them. So first, review from Friday. If I ask you to find the domain, when we were finding domains, what did we do? What was your homework Friday? We know the bottom cannot equal 0. So x squared cannot equal 4. So my domain, square root plus or minus x, cannot be positive and negative 2. So that means this one would have, where would my vertical asymptotes be? The vertical asymptotes, I said, are at those domain problems. So it is when x is equal to plus or minus 2. So domain, they don't exist on the actual graph, so it's not equal to, but the asymptote, that dashed line, is equal there. All right, B, what's my domain? We know x minus 1 can't equal 0, so x cannot equal positive 1. How did I ask you to write it? Infinity to 1, union 1 to infinity. So that means this one, where's your vertical asymptote? 1. X equals 1 is your vertical asymptote. So the domain and the vertical asymptote are related. All right, C. If I were trying to find the domain, we know that in a fraction, the bottom cannot be 0. So what would you have to do on this one? Factor. So I'll put x plus 7, x minus 3. So x cannot be what? One more from Friday. So domain, we do not care about the numerator at all. We are only looking at our denominator. So if we look at the bottom, x to the 4th minus 1 cannot be 0. So x to the 4th cannot be 1. How do we get rid of the 4th power? 4th root you do an even root, what do we have to put with it? So x cannot be plus or minus the fourth root of 1, it's just 1. So that's from Friday, finding our domains, and you will have some homework problems again asking that today. Domain, all you look at is your denominator. Denominator cannot be 0. The new piece for today then is to find all asymptotes. So let's take a look at this one. Vertical asymptotes are like finding the domain. It's what makes the denominator 0. So 4x squared equals 1. X squared is 1/4. How do you get rid of an even power? With it, we would do plus and minus. So, my vertical asymptotes, there are 2 of them. X equals the square root of 1/4 is 1/2, and negative 1/2. So vertical asymptotes are x equals anything that makes the bottom 0. And we have to write them as x equals because that's where our dash line would go. Horizontal and oblique. There are different rules we can memorize, but really to decide it, it's kind of the same each time. One way to think of it is like a division problem. This means you are taking 8x squared minus x plus 2 and dividing it by 4x squared minus 1. Okay, so in long division, everybody pay attention because it's been a while. You start here. What is 8x squared divided by 4x squared? It's 2. Okay. From here, you can continue your division. You know, now you would multiply and get 8x squared minus 2. And we always have to change our signs. Those cancel and we would have a negative x plus 4. Can you do negative x divided by 4x squared? You'll have an x on the bottom, right? So this is basically giving me the remainder. Your asymptote is the quotient when you ignore the remainder. So once I got to this point where it's just a 2, I know I can't have anything below that. Everything below is going to be my remainder. So it's just y equals 2. And if it's y equals a number, that is a horizontal line. So this one has a horizontal asymptote at y equals 2. So horizontal and oblique, you will never have both. It's one or the other. And you find them by doing the division and ignoring the remainder. Okay, so we do our quotient, ignore the remainder. Let's look at B. Can you look at that and tell me what my vertical asymptote would be? So to write it, we always do the equation, so we will say x equals negative 4, because that's what makes the denominator 0. Okay, to decide horizontal or oblique, it's basically setting up a division. You have the top divided by the bottom. What is 3x divided by x? 3. After this, am I going to have anything else? When you divide, it's always the powers go down, right? You can have an x squared, an x, a constant. But if I'm starting with a constant, everything beyond that is just going to be my remainder. So I don't have to finish my division. If it's just a number that's horizontal, y equals 3. And so it turns out these, my horizontal asymptotes, are because the highest power on top and bottom, if you take 8x squared divided by 4x squared, you get 2. If you take 3x divided by x, you get 3. It's because we have the same degree on top and bottom that it works. Any questions on those two? Let's do some more. How do I find my domain? Find out when the denominator is 0. So domain, vertical asymptote's the same. What happens if you do the square root of a negative? You get an I. Can we graph those? No. So what that means is this time there is no vertical asymptote. There is no real number that makes the denominator 0. All right, horizontal or oblique. We can set it up the same every time. If we divide, it's top divided by bottom. So it's always the inside divided by the outside. Can you do x divided by x squared? No. So that means we can't divide them. It's just like a 0. So my horizontal this time is y equals 0. And it happened because the bottom we have an x squared. There's like 0x squared on top. And if you take 0x squared divided by 1x squared, you get 0. So that's why the rule I said you divide those leading powers. You have to think about your highest power of x. D. What do I need to do to find my vertical asymptotes this time? Take out your x. You need to figure out when this is 0. So then that would factor, multiply to -2 and add to -1. -2, +1. So how many verticals do we get this time? 3. X equals 0. X equals 2. And x equals -1. Right, to find out horizontal or oblique, we divide. It's the top divided by the bottom. So when you divide this, you divide the first terms. What is 3x to the 4th divided by x cubed? 3x. Minus 3x. Then we multiply. So you have to take 3x times this whole thing. So that gives me 3x to the 4th minus 3x cubed minus 6x squared. Then what do we do? Subtract those off so we change all of the signs. And now we add like terms. Okay, so positive 3x to the 4th and negative 3x to the 4th cancel. I might have a 3x cubed. We didn't put in zeros for our missing powers of x, so things aren't lining up perfectly, but we don't have any other x cubed, so this just comes down. A negative x squared plus 6x squared would be 5x squared. Okay, so our quotient, we can have decreasing powers of x. So this was x to the first, there could still be a constant. That's what we're finding. So if you divide 3x cubed divided by x cubed, we get 3. And that's all we need. Is this a horizontal line? No. That's then an oblique. Y equals 3x plus 3. So at this point, we have really seen all the possibilities for the horizontal and oblique. Vertical is always what makes the bottom 0. Horizontal and oblique is always like a division problem. But there are shortcuts if you recognize them. The first two examples we did, we had the same power on top and bottom. X squared and x squared, that was my highest power. When those are the same and you divide, 8 divided by 4 is 2. Okay, x and x, I have the same highest power on top and bottom. So you can divide. 3 divided by 1 is 3. This one, I have an x squared on the bottom. I don't have anything that high on the top, so it's like a 0x squared. So then 0 divided by 1 is 0. Those are all horizontal. We got an oblique on this one because the highest power on top was 4, and on the bottom was just 3. You get an oblique when the top exponent is 1 higher than the bottom. And there is no shortcut there. You absolutely have to do the long division. Okay, so anytime that top power is 1 higher, that's going to be an oblique. Y equals mx plus b, and we have to do that long division. But the good news is you don't have to do the whole thing. You just have to get your quotient. Okay, and you can ignore that remainder. Let's do a couple more. All right, so if I set the bottom equal to 0, that would factor into x minus 2, x minus 3. So my vertical asymptotes are Can anyone look at this and tell me if I'm going to have a horizontal or an oblique? Oblique. The top is 1 higher. So if it's oblique, is there any shortcut? No, we divide it. So I'm taking the top, the x cubed minus 8. You can leave it like that. If it confused you on the last one to have things not lining up, you're welcome to include your zeros for those missing powers. Okay, we know if it's oblique, it should be y equals mx plus b. So we just have to get those terms. So we start out. What is x cubed divided by x squared? X. Then you multiply. So x times this whole thing. Which gives me x cubed. 5x squared plus 6x. We have to subtract it off, so we always change our signs. Then x cubed and negative x cubed cancel. 0x squared plus 5x squared is 5x squared. 0x minus 6x is negative 6x. Maybe it can come down. What is 5x squared divided by x squared? 5. Do I need to keep finishing this division problem? Nope, that's what I needed. Y equals mx plus b, x plus 5. That is my oblique. All right. This one, vertical, what makes the bottom 0? 0. Okay. Horizontal or oblique? So the cases where we saw horizontal, was when the degree on top was the same or smaller than the bottom. We got oblique when it was one higher. If you divided this, what is x to the 8th divided by x to the 5th? X to the 3rd. Is that a line? No. If the top is more than one bigger, there is no horizontal or oblique. So you do not have to have all asymptotes. And that happened because if I divided them, it's no longer a line. Any questions for me about these asymptotes? You're probably not feeling super confident on it yet. That's okay. We are going to do it every day for the rest of the week, okay? And probably still some next week. So we are going to get a lot more practice. Do you guys understand where I'm getting them at this point? Last slide of the day. X and Y intercepts, just a refresher. We have done those with lines. The rules still apply if we're talking about rational functions. What is an x-intercept? Where the graph crosses. Good. And how do we find it? Here on the x-axis, y is equal to 0. So if I ask you to find an x-intercept, you plug in 0 for y. You're looking at where you cross the x-axis. A y-intercept is where the graph crosses the y-axis. And you find that by setting x equal to 0. So it's always opposite variable equal to 0. That has not changed. So this is our stopping point for today. There is a Math Excel assignment open.